Hi, my name is Dennis Chin, UR14CS319, and I am here today to explain the role of a predictive parser and to write a program to parse a given string using non-recursive predictive parsing for a given grammar. What exactly is a predictive parser? Well, it's a kind of a top-down parser built from a set of mutually recursive procedures, where each such procedure usually implements one of the productions in the grammar. So yeah, it's a recursive descent parser, and it does not really require backtracking. Uh, yeah, but the grammar associated with it, if not left factored, cannot avoid backtracking. A form of the recursive descent parsing that does not require any backtracking is known as predictive parsing. We have our algorithm here, and let's move on to our code. We'll start out with the output here. So as you can see here, first they ask us to input the number of terminals, the number of non-terminals, starting non-terminal grammar, all the terminals, and then all the non-terminals. We have given, and then it gives us the the prompt for entering the row entries of the transition table. Likewise for the other one, and once we enter all the row entries for the transition table, we move on to the input for the parser, in which we enter the string. Upon entering that string, each of the characters, the input is checked, and the input is analyzed accordingly and parsed according to the predictive parser procedures, rules, and regulations. So that's our output here. Now moving on to our code. First, we do have our header files. The header files are once the header files are implemented, we have our class, a main class here, the one of our classes here called ArrayStack. Inside here we have an array, which also has variables such protected variables of int and top. Inside the array stack we have set as size is 20 and top is -1 because there's nothing as there as of now. Once the top plus 1 is greater than or equal to the size, then when we have our overflow exception here. If top plus 1 is less than size, then we have the array of plus plus top equal to I. We have our code for popping and displaying items from the array. And now moving on to our main class here, we have a class called parser. Okay, so first our goal is to set the IP to point to the first symbol of the W $. So yeah, so and then we let X be the top stack symbol and the symbol pointed to by the IP. And if the X is a terminal or forward, then we set X equal to A. And then we pop the stack and advance the IP, increment the value of it. Or else we display an error. And okay, so here we have our alpha set and state set. We have the array list, string, alphabet, and the alpha. We print and input the values of terminals, non-terminals, the starting non-terminal in the grammar, and we prompt the user to enter the terminals accordingly. So we have a for loop here for the terminals. If I is equal to 0, I is less than alpha set, I plus plus. So yeah, that's all for the entering the value of the terminals accordingly into the list. Likewise, the same is done for the non-terminals, and Yeah, for the entries of the transition table, we have our code here for int r is equal to 0, r is less than alpha set, r plus plus. String int I is equal to b r dot read line, we read into the transition s, space of sr is equal to set to int I. Followed by that, we have the input to our parser. Yeah, so once we enter the input to our parser, then yeah, like I said before, we said the we push the stack and then push the state into 0. System.out.print the value of the input and the output of the stack, and then we have string character space, and we follow that up with the input of character at the value of index. We have the same thing for index 1, alphabet index of character 1. The same thing for index 2. If it does not equal, if the transition of index 2, index 1 equals null, then we print that the given string is not acceptable. Yeah, so if x be the top of the stack symbol and the symbol is pointed to by the IP, then yeah, and if the x is a terminal, then we pop x from the stack and increment the value of the IP. Else we pop x from the stack and push y onto the stack with y on top. Yeah, so that's that. And then here we have the same. We pop the value, and then if ch is equal to the character 3 index, we increment the value of index. Else if $sign shows up, then that means the end is there, and we push the value of ch. If input character at index -1 is equal to $, then we print that the parsing is successfully completed, and 1 and 0 for repeating the program. So as we've seen earlier, our output is displayed here. At the very end, we have our table here that is parsed, successfully parsed. And as you can see here, our $sign indicates the parsing is successfully completed. I'm going to go ahead and give 0 here. And yeah, that concludes our program here. Thank you.